All right, now we're going to look at working out the volume of a frustum. Okay, so a frustum of a cone is formed when we remove the top of a cone with a cut parallel to its circular base. So in this case here, we're removing this top part of the original cone and we're cutting it parallel to its circular base. So once we've removed that and so imagine we've cut that off, now we're just left with the bottom part here. That is the frustum. Now to work out the volume of that, we simply have the volume, so if I write volume of frustum equals the volume of the complete cone, so the whole cone, I'll just put complete cone, and we simply subtract the volume of the cone removed. Okay, so the volume of a frustum equals the volume of the complete cone, so the whole thing, minus the volume of the cone removed. So it's simply this large one minus the small one on top. Now, because we know the formula for working out the volume of a cone, this becomes very, very easy. So we know that the formula is, for a cone, 1/3 pi r squared times the height. Okay, so that 1/3 pi r squared times the height gives me the volume of the complete cone, so the larger cone. And then we simply subtract the volume of the smaller cone, so the cone that is to be removed, which again has the same formula. So 1/3 pi r squared times the height. Now let's have an example with some numbers in there. Let's take this example here. Okay, so we've got all of our measurements in, and let's just assume that they're in centimetres. Okay, so remember our formula is the volume of the original larger cone minus the volume of the cone that we're removing, okay, and that will give us the answer of the volume of the frustum, the bit that's left over. Okay, so we know that the formula for volume of a cone is 1/3 pi r squared times the height minus the same, so 1/3 pi r squared times the height. All right, now what we need to do is go and fill in the formulas with the values we've been given. So let's look at this one. This is the volume of the larger cone. So again, it's going to be 1/3 by pi, because that never changes, by the radius. Now the larger cone, our radius down the bottom is 10 squared, and our height is, for the larger cone, 16 minus the values for the smaller cone. So again, it is still 1/3 times pi times the radius. Now the radius of the smaller cone is 5, so 5 squared times the height. The height of the smaller cone is 8. Okay, now if we go and work out those values, so here's my larger cone here, minus the smaller cone. Sorry, I couldn't fit that all into one line for you, so just so you can get a better look. Now if you type that into your calculator, the volume of the larger cone should come up as 1675.51, and the volume of the smaller cone, so subtracting the volume of the smaller cone, and that should come up as 209.44. Now if you subtract 209.44 from 1675.51, you should get the answer of 1466.07. Now that may vary depending on what you rounded your decimal place to. Now remember, if this was in centimetres, then because it's the volume, it would be centimetres cubed. Okay, so 1466.07 centimetres cubed is the volume of the frustum, which, if I rub out these little bits, is that section of the cone.